Thank you. We are going to spend the next few minutes diving into automated resilience and how to use Argo Events for real-time incident remediation. I'm Darko, and I'm a software engineer at Pipekit. Just a brief introduction to Pipekit. We are a group of Argo maintainers and experts who regularly contribute to Argo workflows, as well as other Argo and open source projects. If you are in need of an SLA on your open source Argo installation, or you want deeper support from active Argo workflows maintainers, we are happy to help. Also, we provide an enterprise control plane for Argo workflows, which makes your airbag life easier, enables the triggering of runs through Git events with minimal configuration, and allows you to view and run your workflows across multiple clusters. Let's say a little bit about auto-remediation. Auto-remediation is the process of detecting and resolving system failures automatically. Basically, your auto-remediation system would detect an issue and try to resolve it. This enables self-healing of applications and infrastructure. You can integrate it with your current development tools or your pipelines to provide real-time mitigation of the issue. For example, you're using some app that works well 99% of the time, but from time to time something happens and your functionality is not working properly. Usually, a simple restart helps, but health check is green. In this case, auto-remediation can mitigate the issue by checking the logs and restarting the service. Later, your team can add a proper fix. This can save money, time, and decrease manual work. How auto-remediation works. There are three phases here. First one is detection. So you need a tool that would monitor your system and act if something is wrong. Then the second step is decision. This component should decide if detected issue is serious and if it can be remediated. The last step is action. Action is actually your remediation action, and this is where you fix or mitigate the problem. Detection is a monitoring tool that continuously tracks your system. Usually, it checks all the logs, metrics, and actions inside your system. And when something is detected, these components will alert. For example, you have Prometheus and Prometheus Alert Manager, and you have a rule that would alert if CPU usage is over 90% for some time. Or you use Grafana Loki and you get notified if something suspicious is in your logs. Let's say a little bit about decision component. This component gets the notification from the detection component, validates it, and acts upon that information. For example, you receive a notification that your system is returning 500 error on some endpoint. Your user is seeing a failure and can't use your system. This notification will be validated, and depending on severity or some other predefined rules, an action will be triggered. And third phase here is action, and action is actually the remediation action. It receives a command from the detection engine, and based on the command starts the appropriate action. This action can be a workflow, a serverless function, or simply a command to revert change in your system. From the previous example, your system is returning 500 error on some endpoints. Remediation action here is to restart affected service or roll back to the previous version if that service is updated recently. A little recap about auto-remediation. Auto-remediation detects and resolves system failures automatically. It reduces downtime by instantly detecting and resolving issues and ensuring business continuity. It boosts operational efficiencies by freeing engineers from repetitive tasks, cutting costs, and reducing alert fatigue. Ultimately, it leads to better customer experience by ensuring high availability and rapid issue resolution. So yeah, let's mention a little bit Argo Events. So Argo Events lets you define powerful event-driven workflows so your system can react to events like failures, security breaches, or business triggers without human intervention. Let's break down what Argo Events is, its core components, and how you can use it to build automated self-healing systems. So yeah, Argo Events is a Kubernetes-native event-driven workflow automation framework. It enables users to define and manage event-based automation using event sources and sensors to actions. So yeah, for example, Argo Events can receive your webhook event and pass it to the appropriate sensor. This sensor will, after, trigger the appropriate action, and in this case, this action is a workflow. So yeah, some of the Argo Events use cases, so you can use Argo Events as part of your CI/CD pipeline. So for example, user commits a change in Git, and then Git will notify Argo Events about this change, and then Argo Events will start your pipeline. Other use cases are, for example, event-based data processing. You upload a file, your file storage provider notifies Argo Events about this, and your processing application starts processing the file. Argo Events can also be used for any automation and event processing. So yeah, let's talk a little bit about Argo Events components. I'm not going to go deep into this. If you want to get more info about Argo Events, you can check Deep Dive Argo Event talk from the previous ArgoCon. You can use the QR to check the talk. Also, you can find other talks and resources at the end of the presentation. So yeah, Argo Events consists of 4 components: sensor, event source, controller, manager, and event bus. Event source defines the configuration for consuming events from the external sources, can transform the event, and dispatches that event to the event bus. So if you want to consume a webhook, you should create a webhook event source config. If you want to consume an SQS event, you should create a SQS event source config. Then, yeah, event bus is a transport layer, and it's responsible for connecting event source to the sensor. Some of the components used for this are Kafka, Nets, Jetstream. And yeah, sensor receives this event and triggers the action. Sensor listens for events from the event bus and does the appropriate action here. And yeah, at the end, controller manager is a regular Kubernetes operator, and it's responsible for managing previously mentioned components. So yeah, now I'm going to do a little demo with Argo Events as decision component and workflow as an action. So entire example is available at the end of the presentation. And yeah, just to set the scene here. So yeah, a bad actor has got into your environment one night and is running a crypto miner in your cluster. Without auto-remediation, you might have some alerting to tell you that there's an increase in CPU or GPU or both, but this will likely go ignored until the morning. So you need a way to act on this scenario faster. In this demo, I'm going to use Prometheus Alert Manager to notify Argo Events that the crypto miner is running in the cluster. Argo Events is going to receive this event, filter it, process it, and trigger the high severity ones. Workflow is then executed. This workflow is going to capture metadata of the affected pods, and after that, it's going to isolate the pod using network policy, cordon the node, scan container image using Trivy, and alert using Slack or PagerDuty. And yeah, some of the actions will be simulated due to time constraint and possible network issues here. So yeah, this is the event source that I'm using. So Alert Manager is notifying Argo Events using webhook, so our event source is creating a webhook. We specify a port, endpoint, and are using post method. Yeah, we also use bearer token for authentication. Argo Events is also filtering all the requests, so we are acting when status is firing, severity is critical, and the name of the alert is crypto miner detected. So yeah, then event source is using the default event bus to pass the events to the sensor. This event is then transformed into more friendly structure. We extract pod name, namespace, instance, and affected container from the event. After this, sensor starts a workflow. This workflow will then use the transform values as workflow parameters. So yeah, this is how my workflow looks like. So we have multiple remediation and data collection steps. Intent here is to quickly capture all the data and limit pod until on-call person is here to inspect. So yeah, first step is to collect the data. I use kubectl to get all the pod logs, pod metadata, affected container image, and I'm saving all the data to S3 for further analysis. Second step is used to isolate these pods, so I'm using the network policy, and after applying this change, both ingress and ingress traffic is blocked. So our crypto miner cannot communicate with the outside world. Then, yeah, I'm using Trivi to scan the container image for some possible security issues. Maybe something slipped there. And then I'm notifying users about this possible crypto miner. So this user will get all the data that we previously saved on S3. And yeah, at the end, I'm cordoning the nodes, so just in case something is happening on the node and if something is wrong there. And yeah, last but not least, so this is the example of the Prometheus Alert Manager payload that I'm going to use. So you can notice status field, alert name, pod name, container name, and instance. So yeah, these fields are important for the demo, and I previously mentioned them. So yeah, let me move this here. Also this, and this. So, yeah. Okay, so yeah, this is the payload that I previously showed, so this is the entire version. And yeah, before I run my demo, I'm just going to quickly show you the role that I'm using for this. So since we are creating a network policy, my workflow needs to be able to create a network policy. Also, I'm getting pod metadata, so my workflow needs to be able to fetch that. And at the end, my workflow needs to be able to patch nodes. So yeah, let me just quickly execute this. And yeah, as you can see, my workflow is started, but before that, I'm going to go here and sorry. Yeah, so here's my auto-remediation pipeline. So this is my webhook, and this is a sensor that I'm using, and at the end, this is the workflow that gets triggered. So yeah, let me go back to my workflow. I need to change namespace here. So yeah, my workflow is still running, I guess, because the network is slow here. So I ran a couple of them previously just to show you how everything looks here. So yeah, this is the first step. Here I'm capturing all the pod metadata, and yeah, this is the message that I'm printing there. And the important thing here is the outputs. So for example, this is the pod description that I'm saving to S3, so you can see everything's there. Then, yeah, I'm isolating the pod using network policy. So, yeah, you can see here that my network policy is created using Argo workflows. Container image scanning. So, yeah, this is scanned. And yeah, at the end, I'm simulating the notification of the user on Slack. And yeah, the last step is cordoning the node. So yeah, my node is now unschedulable, and yeah, other applications cannot use it. So yeah, this is like the quick demo that I did today. So yeah, let me just go back to my presentation. So yeah, we saw crypto miner alert simulation. Prometheus Alert Manager event was used to trigger Argo Events. And Argo Events filtered this event based on severity and alert type. Then the remediation workflow started. This workflow captured the pod metadata and saved this information to S3. And after that, we isolated the pod using network policy, cordoned the node, and scanned container image using Trivi, and alerted on-call person on Slack. So yeah, I already mentioned Argo Events. So RabbitMQ is a valid choice for using as a decision maker. So yeah, why would you use our RabbitMQ? So yeah, one of the issues with RabbitMQ is that it's not a native Kubernetes app. So yeah, you cannot easily deploy that to Kubernetes. Also, RabbitMQ is a basic message broker. You would need to create a producer that needs to receive this event. You need to validate this event and need to pass it to the RabbitMQ. So after that, you would need a custom consumer that would get that event and trigger the action. So if you need to add multiple event sources, you would need to add additional code for each. And at the end, RabbitMQ is not easy to scale, and it's not lightweight. Also, for example, you can create a custom app as events handler, decision maker, and this is what some people do when they have one event source. People might write a custom app with good intentions. This app does one job well, but then you need to add a new feature, and you have to keep manually growing it. In this case, you need time to develop and support this application. You need to implement every new event source, no monitoring out of the box, no built-in fault tolerance, extra work to secure everything, so a lot more time and money needed to maintain and develop the application. So why Argo Events? So as we saw here, Argo Events is great for event handling. It supports many sources and destinations. It's open source and container native. It's basically plug-and-play system. It's not hard to scale it and add different sources, and it's really easy to maintain it. It supports basic filtering and discarding of events, and if you need something more complex, you can easily add a workflow that will do that for you. You can also combine multiple sources and trigger only when you get the same issue from multiple sources. So yeah, for my demo, you could use Alert Manager and, for example, AWS Guard UD to detect crypto miner, and only if you get a notification from both of them, you can be sure that something is happening, and this is really easy to do with Argo Events. So yeah, what are the best practices for auto-remediation? So you should validate the event and filter it. You don't want to trigger your auto-remediation action every time something happens, just when it's needed. You should also add a retry policy and DLQ in case something fails during the processing, make operation idempotent, or do event deduplication. So yeah, you don't want to trigger the same action multiple times. You should also add alerting and monitoring to your system, and at the end, you should really test your auto-remediation pipeline. So simulate and observe what is happening inside your system. So yeah, why would you use this? I already mentioned Argo Events benefits and why it's great. I also mentioned that by automating your on-call playbook, you can minimize the errors. Automation can act faster than the on-call person. Imagine something happens at night, on-call person is woken at 3 a.m. and needs to fix the issue. Of course, something can go bad. This will also improve your infrastructure and reduce operational cost and manual work. By automating responses to recurring events, engineers don't have to manually troubleshoot the same problems over and over again. This eliminates alert fatigue and lets them focus on innovation rather than firefighting. You can also detect security anomalies, trigger immediate mitigations like revoking compromised credentials, and ensure compliance by enforcing policy-driven remediations. So yeah, let's do a quick recap of what we saw today. We saw a little bit about Argo Events and what Argo remediation is. We saw crypto miner threat simulation, how to use Argo Events and workflows to remedy it. And at the end, we saw some best practices and benefits. So yeah, thank you for coming. On the link, you can find other Pipekit stuff and use this QR code to get free Argo resources. Finally, if you have any Argo Kubernetes questions, do come and find us at booth S590. Throughout KubeCon, we will be happy to help and chat. So yeah, thank you.